Let's start. Hello, Ditch Gamer, Harp, Mary, Sabah, Shadow, Shaza, Stewart, Teddy, Jesus. Hello, Ayub. How you doing, guys? كيف طلع زي الفوق انت؟ Hello, West. Okay. Let's. So today we have 3 LeetCode. Next day, 3 another LeetCode. So we're gonna keep going until the end of these 3 months with like 3 LeetCode, something similar, following the same plan of the tech interview handbook. So in week 5 we have to do all of this, or and using what we learned in the week 4. And we keep going until we reach the monster in the week 12. This is all hard. If we solve one, I will be happy. Okay, let's go to the first one today. Is this one? I believe we did it. So we have 2 sum given an array of integer num and an integer target. Return indices of 2 numbers such that they add up to target. You might assume that each input will have exactly one solution, and you might not use the same element twice. You can return the answer in any order. Okay, who wanna jump to the mic and say what he understands or what he doesn't understand? Please don't be shy to talk. Use this space to like get over public speaking fear. Maybe we see the example and see. So we have array nums and we have target 9, and the return was 0 1. So index 0 and index 1, they give us target. So 7 8 9 plus. So given an array of integer nums and an integer target, return indices of 2 numbers such that they adapt to the target. So Shaz, I think you have echo. So we have a list of array numbers, and we need to see which 2 elements here. If we add them together, it's gonna give us target. Okay, is the problem not clear for someone? If not, we can clear it. Okay, so here the problem. Let's do the first one. We have, yes, go ahead please. 7 11 15, and target is 9, and our program is this. It's a 2 sum. We give it a list and we give it target. Now using what we learned before, what could be the solution? You know, what could be the way to do it?
The only thing I can remember here is that we make use of dictionaries to keep like a track of every element with its index, as far as I can remember. Like a dictionary which contains first element is 2 with index 0, 7 index 1, and depending on the complement, which is the difference between the target and the element itself, we may put a condition if we found the same complement in the dictionary. So we may find the indices of the element and its complementary item to reach the target. So to make it simple, we make use of dictionary with element and its index. This was the start, I think.
Okay, let's say this is the dictionary or hash map, and we have key value. So what do we do? Like, do we loop through it and do something with the hash map?
Yeah, I think we loop the list to populate the hash map.
I, I think the same idea with the hash map, but what you are doing is technically like so the array in let's say the first element of the array, what we need to do is to check each each of the other elements in the array, which one of them, if you add with the other elements in the array, which one will give you the target. So for example now, if I'm checking with 2, check you use 2, then you check 7, check 11, check 15. So that's like brute force method. So you do it for every element of the array. So since you have checked with 2, you don't need to check what do you call it? You don't, for 7, you don't need to check with 2 again. So you have to do that's like brute force method. So for the part where you have to use the hash map will stop. So for example, if you check 2 with 7, you store it that I've already checked 2.
Do I
in the
store it?
hash map. Yes. So what you'll be looking for will be the target minus the index.
So I keep checking 2 by 2 and storing them and check if targets exist here.
No, you are checking. So for that element now 2, you check if 9 minus 2 in the array, then you store it.
Minus 2 in the array, then we store it. Okay, let me repeat because I saw lots of people just join. Just to repeat the problem so they can follow with us. So the LeetCode we are solving is this one. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to targets. You may assume that each input would have exactly one solution and you might not use the same element twice. So for example, they give us this array and they say target is 9. Now we need to find the two number that if we add them, they give us the target, and we assume there is one solution. And I think this you might not use the same element twice. So then Shaza suggests the hash map, and I think also we did use hash map. I believe we solved this before. Now, you can continue. Hard.
Okay. So since we're going to be returning the index, so we'll be saving the index of the element in the hash map. So the key will be the element, and then the index will be the value.
Okay, the key gonna be okay. So like, so index 0, 1, 2, like this.
Yes, that would be the value. So, for example, how do I explain?
And there,
I was watching a video about it.
So if you make the key the value, you might have issues when you have duplicate values.
Oh, okay. So we can make the key index. So index 0.
But then you need to return the. Okay, you can also return the key.
Wait, maybe there's no. Okay, there is some solution for each element in the list. Okay, you wanna like explain, Ningase?
Okay, mine is of O log n, I think, if worst case. But essentially, you don't need to start at the first element because that's the first element. You add that element to the dictionary, and then you begin with the second element, yeah? In the list iteration as you're going through the elements. So you add the first element to the dictionary as you initialize the dictionary. and then the value next to it can be something like 0. It doesn't really matter. So the key is 2, and then the value is 0. And then as you loop through, the
2.
key, yeah, then the key is 2. And then we start from 7 going forwards. So what you do is you take 7 minus 9 at each element iteration, right? Because 9 is the target, so 7 minus 9. And then you check if that will equal is 2, right? Then you check if the dictionary has the element 2. If the dictionary has the element 2, that means you have the 2 values required to make the target. However, if 2 does not exist in the dictionary, the else would be that you add the 7 to the dictionary as well as the value 0, and then you move on to the next one, and then you do 11 minus 9, and then again you check 11 minus 9 would be 3, I think, 2, and then you check if 11 minus 9,
We can change the target to make
but that
it
would be
work.
negative.
So
Can I suggest some? Can I
Then just
No,
stop
but
it there. Leave the target minus elements. So.
can I ask a question?
yes, go ahead.
Okay. Is the array always sorted?
No,
Like, is
I
it
don't think so.
Your
always
second
sorted?
example, it's not sorted.
No, it's not so.
I'm thinking we should first. Okay, it's fine. I was thinking we should first sort it. Then at least we have to know the number that is close to what our target is. So we start searching from there. But it's okay. You can go ahead with Agassiz method. There are many ways to solve it. So yeah, Agassiz method will make sense as well. So, but that's what I would do if I want to solve it. I'll sort it. Then I'll look for the element that is closest to it, like discard the rest and focus on that particular index, like the range that can give me what I want. It's like you have numbers that are higher than 9. So why would I have to go to start checking for 10 and 11 and stuff like that? You get? So I will limit the index to where I know I need to find 9. You understand? That's what I will apply.
Possible.
Can you repeat, Saba?
Possible in the
I think the echo cancellation is cutting your voice. Try get close to the mic.
I meant are negative values possible in the array?
They didn't mention, but I think it will.
Can you
work.
scroll down? Yes. So they are possible.
Okay, where did you?
The second constraint. Yeah.
What that means?
So even if the value is bigger than the target, there can be a negative value that lowers it.
Okay, let's be aware of that. That's the
they can be negatives. I see.
target and the elements inside can be negative, and target also can be negative. And okay, so we can try do simulation for this solution with the hash map. For example, so because this example is 9, it's gonna work with the first 2 elements. Let's try to make it work with 12 and 11. So let's change the target to 13. 8. So if the target was 13, we should find these two. So we go first, we add this to the array, to the hash map. We don't care about like what it's called, the value, so we put just 0. Then we check, so 2 is always gonna be the first. Then we go to 7. Then we do 13 minus 7. What is that? 13 minus 7? 6. So 6. 6, we check if 6 exists here. If it doesn't, if it exists, it mean but how are we gonna return the key? So let's say 6
we can do a range. Oh yeah, that could be the key actually. The value could be the key.
value, the key, yeah. So we can do like E here. And
No, but it's best we just do the range, no?
the range.
I don't know. Maybe for the for loop.
Sorry, is it a
Keep-
must
Why
that
not?
it has
Why
to
not just?
it has to be 2? It has to be 2 index. Like is that what the question is asking?
Yeah, so like the question is like I give you this array and the target is 13. Now find the first 2 number that you're gonna add them together and they're gonna give you 13. So we start from here.
Okay, what
Yes.
about if there are other numbers there?
They remove that by saying we might assume that each input would have exactly one solution and you might not use the same element twice.
Nice.
So it's more simple now. Now the question is like,
All right, nice one. Thanks.
you're welcome. If we follow with this technique, we're gonna reach a point where we need to return the endis. So how are we gonna do that? We
So-
can
I'm thinking, why not make the value of the hash map as the value? Let it be the index.
I think that will be nice. Yeah, we can try it. Let's keep going with simulation. So we go 7 and 13. It give us we said the value is 6. So we go look here. 6 doesn't exist. That means we need to move on to the next target. But we're gonna add this to the hash map, right? So any element we finish, we add it. Now we move here and we have 11. 11 minus 13.
Sorry, how are you keeping track of like in case you find it? So how do you return it? How do you know that okay, this is the number, this is a 2 index? Because the hash map will contain so many index, right? So how do you know the exact index that gives us the solution?
So let's see it here. So we reach 11, right? 11, we did 13 minus 11, it's give us 2. Then we go check the hash map. We can check it with like if 2 exists in the keys. We can do like if 2 in hash map, right? This is gonna be true if in the hash map there is key 2. Now when we did 13 minus 11, it give us 2. We found it here. So that means one of these number that we pass before in the past, it is exactly 2. So that means if we add this number to some number we pass in the past, it's gonna give us 13. So how we can know the index of this? Because we are now looping through 11, so we know the index of 11 is 0, 1, 2. But how do we remember the number of this?
We can do it by
The key?
to look maybe.
Or maybe save it in the key?
Yes, we save it as
In the value?
values.
But
We do enumerate in the loop and we save it in the value.
I think that will work good. So every time we pass, we save these numbers, so we just save their index there. And then we return it. We return the index of this one and index of this one. Okay, I think that's cool. If someone didn't understand it or have question, don't be shy. We all here learning. So just open mic or write in the chat. Okay, there must be someone didn't understand something. Don't be shy. Come on. Come on. Come on. Where are you? Wake up.
Sorry. I have a question, sorry.
Yes.
Okay, now the thing is, how are you subtracting? Are you subtracting the targets from the value in the array, or you're subtracting the value in the array with the targets?
The targets
Is it 13 minus?
Yeah, 13 minus 2.
What is in the array, right?
Yeah.
Okay.
Yeah. So I'm going like
that's
this, and
Okay.
this, and this. Yeah.
Okay, nice.
Okay, let's convert this to code. I think Ningasi already did the code here. It's like pseudocode. You can like start with it. Okay, let's see if it represents what we discuss. Okay, we did create the hash map, right? It is right here. We said the first elements we're gonna always add it there. So how we can do that? Do we like just put it here directly? Like what's the list called? Nums. So like nums index 0 dot 0.
Yep.
So basically we put 2 and the index 0 because it's index 0. Then for each element in the list, so
Oh no, I changed that. I changed that into a range.
okay, let me copy it. Okay, and then okay, I think backward style gonna give you error. Okay, so for index in the range 1 len list. So that means we're gonna keep looping until we've reached the end of this list. A lot of noise. So we're gonna keep looping on each number, and then if the target minus element index, element is mean num.
Sorry. Yeah, nums. Even the range in len nums instead of len lists for the for loop. It's
for
length of the nums.
Yes. So this array is nums in dictionary that we call here. So what we're saying is like if 13 minus because we're gonna start from 7, that's why there is like 1 here. So 1, it's gonna allow this loop to start from here. Alright, I'm wrong.
Absolutely.
I believe so, yeah. Okay. So because we're gonna start here, we're gonna do target minus num index and index 1. 1 means 7. 13 minus 7, it's gonna be 6. 6 doesn't, we're gonna see. We're gonna check if it exists in the dictionary. If it exists, we're gonna follow this line. If it doesn't exist, we're gonna follow this one. So in this case, what we're gonna do?
You have to change the element as well in the else to nums. Else.
Nums, okay. Nums. Yes. And here too. Yes. What else? Okay, yeah. So we said because 7 and 13 is gonna give us 6. So this number, so 6 we don't have in hash map. So automatically we know that the past of this number, it will not give us target. So we keep moving, right? But when we're gonna move to 11, we need to archive this number, right? So we can go back maybe in future to it. So that's what we're gonna do. And else we're gonna add this to the hash map. We did nums index 7 and the value is the index, which is gonna be 1. Index 1. This index 0. And then we're gonna loop again. This time we're in 11. 11, what's gonna happen is if target, so 13 minus 11 is gonna give us 2, and then this condition in, it's gonna check if 2 in dictionary. We're gonna find it. There is 2 right here. It's gonna return. Okay, what's it gonna return? It's gonna return an array. What's inside this array is dictionary get target minus nums. Okay, so it's gonna get the 2 as a key. So maybe we can just to read it better. We can do call it something like.
So yeah, I have a question.
Yes.
So are there cases where we can have 2 twice in the array? Because if you have 2 twice.
Case.
Okay, so the way you wrote this dictionary now, is it not going to override it?
It's gonna, yes.
I don't know if you get what I'm saying.
It's gonna, yes, but we don't care, I think, about that because we're gonna see the first 2, or yes, there is a possibility it's gonna be the second 2. Maybe they don't care. Let's see.
Yeah,
Yes,
you could create a clause to check if that particular key that you're trying to add already exists. If it already exists, then there's no need to add it again, I suppose. If we're just looking for the first one.
Okay, I think this one. You might not use the same element twice. What does that mean?
It means if you've already added a 2, there's no need to add it again. You're just going for the first 2 that was found.
I think it means that, for example, if we have a 10 and you go through a 5, you may not use the 5 twice.
If you have
Unless you have 2 5s in your array. I think it is safe. I think it's safe from double value.
I think it's safe, yeah. I think it's safe. It's safe.
Yes, if it has any number equal to the target, what should return?
can you repeat the sum of any number?
There are not exist, or they're not equal to target.
Oh, that's a good question. What if we didn't find it? What should they return?
-1, baby.
I mean, they said there's
I think they say
exactly
this
one
thing-
solution.
Exactly.
So
That's
of
what I'm
course
saying.
there's gonna be a solution.
Okay. You guys asking a very smart question. Nice work, guys.
There's perhaps another edge case. What if there's one element and the value that you're looking for as a target is a 4? Does that mean that one element becomes, what you return is a 0, 0 in that particular case?
Oh, what if this was 13?
0, 0 maybe.
Is this what you're saying?
No, I think it must be 2. It must be 2.
13 and 0?
It has to be
So
some, I think.
this
It can't be
2
1.
was-
Yeah, if there are 2 elements, that's correct, but it cannot be only 13. That's against the...
Exactly.
Okay.
What if it's the target is 4 and then there's just one element in the array and it's a 2?
Target is 4 and there's 2 elements, 2, 2?
Safe to say that there
no,
cannot be only
That's
one
what- that's
element
what
in the array.
That's what I'm
Oh,
saying.
okay.
That if it was 4 and it's 2, 2, how will this not affect the dictionary? I don't know.
That's a good question. But how are we gonna do this? Is this gonna
Cross
work?
that bridge when we get to it.
I'm now curious. Let's
Let's
test
just
the
test the
code.
code, okay?
Yeah, let's test.
Forget about this. All this, yeah. Let's test the code.
Okay, now we are doing our let's code, I guess. Let's see. So, 2 we added. It have 0, and then we're gonna check the element 2. This one we're gonna check. I did create this key just so like we can read it easily. It is the same. So the key is gonna be target minus num index. Yes. So 2 minus the target is 4. So 4 minus 2, it's gonna give key. It's gonna 2. It's gonna see if the key in dictionary. It's gonna yes. Then it's gonna get. It's gonna get that key index and the current index. It's actually working. Yeah.
It still works fine.
Yeah, it's work because we are here. This index is we're still gonna return this. So it worked fine. Nice. Okay, and then what if happen? We said if the target not an egg return, it's gonna return -1. If the target there is no two number in the array that give us this sum.
Yeah, but I think the boundaries of the question already specify that an answer will exist.
You can just return empty lists.
Yeah. Yes. We can do that. Oh yes, I think that's true because this may give false negative.
Yeah.
Like false positive.
That's the last index of the array. The
Okay.
two last index of the array. Oh.
So the last index -1.
The -1 is last index.
Okay, so we tested, see if it's gonna work. So else it is else will okay.
Check the indentations there, and the return shouldn't be capital.
Okay. Dictionary gets. What happened to color? Okay, now we said give it this. Then range target is this one. Index. If key in dictionary index. This one should.
Is that key not a tuple, if I may ask?
Key.
On line 6.
Yeah, you don't need the brackets. Yes.
Okay. Index.
And then the return on line 7. No, line 7 as well. Oh no, that's fine. Sorry, forgive me.
Yeah.
Forgive me.
We're not even reached the last line. Yeah, I don't think we're gonna reach this. But what happen if I guess
-1
it's gonna just
maybe
the syntax
for the length.
line 4. Oh, what the hell is this? Oopa! Submit?
Congrats.
Hey, wow! Look at that! 61. 64.
That's Iangaz's work.
Yeah,
Nice one.
Nyangasi, let's sign it. Nyangasi
61%, I'm
was
ashamed.
here.
I should be getting
Sending
200%, yo.
respect. Huh?
That's
Can you
passed
repeat?
now. You passed.
Okay,
Yeah.
who have question about this? Let's code before we jump to the second one. Anything about code or like pseudocode? Don't be shy. Open mic, talk, or like write your question in chat. Okay, now we finish this one. We jump to this one. Now this one is a bit tricky, but I believe we did it. I'm not sure, maybe we did. So valid parenthesis given a string is okay, let's see Mahmoud's solution. Didn't see it.
This bad solution before I joined the
Oh, how did it do it? So you did array, you did
How
true
long is
loop.
it that?
in the square.
Is this C? I think
the
it's
square.
C.
Best.
It's just C, right? Language, C language?
Okay, best.
No,
Oh, nice, nice.
JavaScript.
Oh, JavaScript.
Yeah, in the square.
Air push. Okay.
Oh, so you
Does it-
find the number and then you search the entire list to see if it has a pair. And then if it doesn't, you move to the next one and then you see if the entire list has a pair.
I guess if it's work, right? Who
Work
cares
is-
about time complexity or
The
time?
time.
Nice
think-
job, Mahmoud.
I think
Nice
if you did in C, it's still gonna beat this one, I believe.
If I solve this now, I will time less than the much this.
Okay, let's do this. What happened to this? This one, Sabah solution. Yeah, guys, if you did this task before, maybe post your solution. I think the coach Minatalize also did it. I'm waiting for your solution. Where is it? This one. So, if okay, this is the index. Okay, I forget what this one does. It's like
Splits them up into index values.
Index and value, yeah.
okay, so you have access bots, and then you have 2 4. Okay, this is similar to this one. 2 4, and you a plus b equal targets, then return them. Yep. If it's work, right?
Can we test it to see the percentage or something?
Let me copy the image and paste it here. Please give me the code, I'm joking. Let's see share the solution. Okay. Shaza was here. Send in. Respect. Submit. Ooh! What? 99? What happened?
Wow!
What's the difference?
Wow!
Just one for
Maybe
loop.
this?
This is very similar to our PLD solution now. It's just one for loop, and that's it. I don't know if there is a difference.
It's that damn len. I bet it's that len.
Did this one?
A similar solution, but the enumerate is just what makes it different. The
Maybe.
enumerate stuff.
Maybe the way, maybe the range. We did use range. Maybe the range is slower than this one.
Maybe.
I think it's
At
the
the end
len.
of the day,
The length. Which one? The length. This one?
The len function.
The
No,
the
no.
length. Yeah, the length. We have two functions.
yeah,
the
yeah.
range. We have like a range, and we have. Yeah, we have range function, and inside there's length. So this two did nice
Yeah, I think
work.
that len is the devil's work.
Can you try this?
Okay.
Sabah and Mahmoud.
Okay. Let's see.
See the time.
Let's see. Sabah solution. Sabah was here. Send in respect. Submit.
Sometimes what I think is calling too much of methods, like an object method, calling
my God.
in a list, and calling get instead of accessing it with the key. directly might also add to the load.
My time with JavaScript less than this.
Okay, I think Sabah, because she's using 2.4, it made it like time complexity long.
Enumerate, I think, uses enumerate enumerate. I think this in.
Okay, but in the end of the day, we are using the same loop. It's for loop. What's inside enumerate that make it less time consuming? I don't know.
But why the time here is? Let me submit again.
enumerate what بتشتغل ازاي؟
It's split. It give you like
No clue.
index and value.
Index and the element. Yeah.
Can
For
access
example, for example, the first element is 2, so it gives you index 0 and the element is 2. You capture it both in the same time.
I think enumerate ان لوحدها ان كذا مرة ان داخل ان ان يعني اوف ان زائد اوف ان فور لوب زائد اوف ان سكوير لوب 2 لوب ان سكوير كتير كده I think.
What's other
so
solution?
we can just add
can you use variable enumerate and use this variable and to see if I'm less than this or not?
I use a variable enumerate to do what?
Enumerate.
You can say it in Arabic if you struggle.
نقدر نستخدم variable فوق ونحط فيه القيمة بتاعت الانوموريت ونستخدم الفاريبل في بدل الانوموريت.
So you're saying so variable then like this then variable like this?
Yes. I think enumerate بتشتغل
change here so variable 2.
No داخل inside first loop. Variable 2 inside
like
first,
this
inside first loop
like this.
No inside the first loop داخل اللوب الأولانية.
Yeah, variable.
Variable 2, you won't have access to index A. You won't have access to index for the loop.
Okay. So like this?
Inside the first loop.
Yes, this is first loop. It's inside. Wait, you mean inside right here?
No, variable 2, not variable 1. Variable 2.
But 2 we need index I.
Yeah, do the same thing. Do what you did outside the loop, inside the loop.
Like this.
Yes.
And then
inside
okay, my bad. Oh my god.
2 not variable.
Okay.
Yeah.
Variable 2. But that's still gonna run it. I don't know.
This دي بتشتغل جوه اللوب بس بتشتغلش في اللوب التانية وهي شغالة.
Okay. If the array is like sorted, maybe can solve this. Minimize the check if the target if the sum less than the target.
try JavaScript كده.
Okay, let's try.
Change Python to JavaScript.
Okay, I think with the variable we made it worst. Mahmoud. Oh.
Bad solution.
Mahmoud.
Best solution. Best.
Send in respect. Submit.
على فكرة يا محمود, even these bad solutions were not coming to my mind even قبل أليكس. أنا حتى يعني الحلول الوحشة دي ما كانتش بتيجي عندي, فأنت في نعمة.
Okay, she's saying you want to translate that in English?
Thank you.
Yeah, I'm saying that before Alex, I wasn't even dreamed to give solutions even in a square or something like Mahmoud's solution. This is good to have a base or background that you even can pass a solution. This is good.
Exactly.
True.
Exactly.
Thank you,
That's
Sajid.
This one is Python. Okay, let's test this one and start the LeetCode so we can do at least today 3 LeetCode if we can. Because a lot of people join late, so basically the upcoming PLD is gonna be about LeetCode. So each PLD we're gonna try to solve at least 3 LeetCode, going through this list of LeetCodes. So we're in week 5, week 6, week 7, week 8, until and you can select medium, and then it's gonna become hard in the last week of 3 months. So
Then we all get jobs.
yes, yep, we will. Now let's test the last code of TD, or also Ayub. So this one gonna be like this.
No. Oh, okay.
So
I just
TD
Yeah,
was here.
it's a two-pointer technique solution.
Okay, I think I copied something wrong. Name error is not defined. Okay, maybe you did copy code not error?
Yeah,
Do you mean num? Okay, what if I change this like this? Wrong answer. Maybe because it should be num. Okay, let's shift this to nums. Submit. Are you sure it did work for you? It's have a wrong answer.
He's returning the actual values instead of the indexes. That's the only correction.
okay, yeah.
Or maybe I didn't copy it, or you did not copy the full code.
Let me check.
Maybe copy everything.
It should be turning left and right, not the nums left, nums right.
Return index.
You see on line 8, it should just be left, right, left, comma, right, instead of nums left, nums right.
Oh, like this. Left. Right. Run. Outputs empty. So left 0, right. Left, right.
What left to right? Return the array, but return the list inside list left and right.
In
The
that
target-
failing case, what was the target?
So the target was 6 and 3, 2, 4. Okay, maybe this should return.
We forget the return noun maybe. The last.
That while loop is problematic. While left is smaller than right.
Maybe you need to add the last line the return noun.
No, the while loop condition is the one that's problematic.
So is
So-
this the same one we solved?
Not sure.
No, this is a new one.
It is, yeah, it's a new one with a two pointers technique.
I mean, it's the same problem to some.
Yeah, it's a two.
The problem is the 5. The while loop condition, the left smaller than right. It will terminate the loop before if that condition.
Okay. To save some time,
Right.
let's jump to the second LeetCode. And let's just keep going. So,
Really nice.
Valid.
Nice. Nice problem.
yeah, it's probably something missing, like Ninga said. For the left, probably the while condition. Okay, let's jump to valid parentheses. So given a string s containing just the character, okay, close, open, close. So combination between brackets and what is this? Parentheses, yeah. And what this one called?
Curly braces,
Curly
square
braces.
brackets, and just brackets.
So determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of bracket. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So this one is close, open and close. This is correct, should be true. This one open, close, correct, true, open, close, true. This one is open but it's closed by square bracket. What is it called? Someone help?
Yeah, I think
Brackets,
so.
Square
yeah.
bracket. Square
Okay.
bracket.
So with square bracket, so is the problem clear? Do we jump to it? Let's jump to it. And move this to the layer. Problem here, if someone wanna take a look. Let's see how we're gonna solve this. Any idea? Come on, we need to pass this interview, guys. What you doing? Wake up. Wake up. Wake up. Stuck. Someone said stuck. So stuck. How are we gonna do it with stuck? So array, for example, we're gonna use array. Let's call this is our stuck.
Yes, I use the stack already.
So
Can
just
I ask
yes.
why did you jump to stack that it would be our solution? What came to your mind?
Yeah, that will be nice if you guys can. If you can't talk, you can write in chat, okay? I can say it out loud.
Go ahead, Marty.
If you wanna like talk.
Yeah. So, hello guys.
Hey, welcome.
Briefly, yeah. So, I thought of stack because it kind of makes sense. Because in the string, I'm thinking what we do is whenever we find an opening bracket, opening curly bracket, opening square bracket, opening anything, we push it to the top of the stack. And whenever we find anything closing, we pop the topmost item from the stack and then we do a comparison. If they are not the same, we stop searching. It's not correct string. But if it is, we just keep continuing. So that's what I'm thinking we do.
So
but this suppose that whenever you come to add to the stack a closing bracket, you are comparing the closing bracket to the last one in the stack. What if it isn't compatible with the last one? It was the one before, for example. I think it doesn't have to be I think the consecutive closing a bracket directly, or maybe open brackets must be closed by the same. They have to be in the same order. Okay, maybe.
Yeah, Shaza, that's great. You know, it's more like a text editor that we use. So the very moment a closing brace or a closing bracket doesn't match the topmost item on the stack, we don't have to continue searching. We're done.
I see. Thank you, Murti.
So I try to follow. So if let me know if I understand. So we loop about this, we push it to the stack, so it is right here. Now when we go to here, we pop this and compare it. But we need a way to we need to compare it with something. We need to.
So how do we identify a closing and an open bracket?
Yeah, we need to. So if I reach here and I reach to the second one, I need somehow to understand that this equal this. Like it's.
So the way I remember doing it is having two arrays, that the open array that has like open brackets, the closing array that has closing brackets, and what you push to the stack is their indexes.
Okay, so two arrays, and
Yeah, and I would totally agree with it because there is a finite number of parentheses that we have. You know, round bracket, square bracket, curly bracket, angular brackets. They are very finite. And so because we know them, we can store them, just like she said, and just use the index. So round bracket opening is maybe index 0. Round bracket closing is index 0 for the second array. And so
I see. So we can do, for example, let's say this array we're gonna save. But why would we need two array? Why not save them all in the same array?
Because they need to have the same indexes, the open and the closing.
Oh. Okay, so this one
We can
close.
even do a dictionary where the key is open, the value is closed.
Oh. Okay, that.
Sabah, I thought of your solution, but I couldn't complete it. I would be happy if we can keep it with dictionary. I couldn't complete it with dictionary.
Okay, let's do it with dictionary. That was good idea. So what she said is we're gonna do key open, and the value is close, and then
That's a good idea.
and then this one like this, square brackets, then the curly brackets. There. Now we can just check. Wait, how we can? So let's say we got here. I think we don't care that much about the first one, right? We care about the second one if it's matched. How are we gonna move through this string?
I think what we care about is the even numbers. Do you understand?
Not really. You can open three brackets and then close them.
Well.
Okay, we still need stack, right? Let's say this is our stack, and this is our comparison hash map.
You do need a stack to save the indexes of the parentheses.
You can use the stack to push every open parentheses, and when you لما تقابل open parentheses close parentheses top the last element and compare these together and like this. yes يعني بتبوش كل البارنسيس المفتوحه، ولما تقابلك اي واحد مقفول بتدبل اخر element قارنه بيه، لو هو القفله بتاعتها خلاص تمام وتكمل على هكذا. ممكن ترانسليت to English.
Okay, so we add them all. I'm not sure if I didn't understand, but like we add them, like we go through them all. We add them.
Can I say something?
Yes.
Okay. What I'm trying to say is, like what the other lady said. I don't know her name. The one that said the keys should be opening and the values should be closing. What I'm suggesting here is, let us go through the odd elements. The odd elements will always be the keys, and the even elements will always be the values. Does that make sense?
The odd element's gonna be always the closed
keys.
The keys.
The
Open.
That's the open.
And even
elements
gonna
are
be
always
always
the
closed. Yeah, that's I think true. That's a smart way to think about how we can.
So, as Mahmoud said, you keep adding the parentheses as you go. If it's open, then you add it. If it's closed, then you check if it's. So you don't add the key, you add the value. So what it's expecting to close. So as you go, if it's the right parentheses, then you pop that last element and you keep going. If it's an open, then you add the value of it, so the opposite of it.
Okay, let's select this idea and try together work on it. Okay, so maybe there is no more idea because there's many idea and all of them are correct.
You can use this example, Musif, because this example will الفكرة توضح أكتر. Example in chat.
Minatullah, we didn't hear you. Can you repeat?
I think maybe it will work if we use the hash map. And the keys is the open value and the open brackets, and the value will be a count. So when we have an open, we add count 1, and when we close it, we remove the count. If the end, the hash map, each key has the value of 0, we know it's valid. If it's not, then it's not valid.
Okay, that's also a solution.
I think
yes.
I don't know how that needs to work, but I was really interested in the stack pattern. The only thing that was left was our ability to know a closing bracket. So if we are able to create a list where we have all the closing brackets, so when we get an item, we check if that item is in the closing bracket. If it is not, then we can add it to the stack. If it's a closing bracket, we pop the stack and compare. And compare with the item. We pop the stack and compare with the item. If it is a closing bracket,
okay.
if they kind of match,
okay, that same idea. Let's work on it. That same idea that Mahmoud said, and the last thing is Sabah said. So we're gonna use stack to like push and then compare, then pop, right? Something like that. Let's start from beginning. How are we gonna start? So we're gonna start loop, right? So loop.
We create the dictionary, no?
Yeah, create dictionary, create stack. Okay, and then loop. Let me zoom. So Shazza, don't kill me. Loop to string.
I will.
Okay. Okay, guys, if I didn't attend next PLD, you know what happened. So loop.
No, I will see you at the end of PLD. Don't worry. Go ahead.
Okay, loop through string. Now our string, we have this first character, open parentheses. What we're gonna do is we're gonna push it to the stack.
Yeah.
Wait. We need to know if it's open or close, right? Because we need to open. We need to push.
We just create an array have just opening. And then so when it just create a array has opening.
This is
bracket
stack,
opening.
And this is dictionary that have like.
I think we can just store the opening parentheses in the something like set or even string, and we can do over them if we want.
We can do it by string, okay.
With the dictionary,
and then check if the مثلا if the index inside this string is this open string, we added a stack. If not, we just compare if close or not.
But okay, is that gonna get us away from the main idea?
So let's try to continue with this. So let's check if the string or if the character is a key in the dictionary. So if character in dictionary.
This one.
If the character is in the dictionary,
okay.
We are going to add it to the
dictionary.
You can add its value to make it easier.
No,
so
if we
add the close.
If we add the value, it might be a little bit complicated because we want to add it to the stack. We want to add the opening brackets to the stack so that when we find anyone that is not in the dictionary, not a key in the dictionary, we know that it is a closing bracket.
So we
try to.
So we append the value, right?
Yeah, no, we append the key.
But the character is coming from the string itself. So like let me write it correctly.
When you say create dictionary, we must have created the entire the dictionary.
Yes, stack dictionary, right?
Yes.
So we check if the character, which is, for example, this one, this is the character.
Okay. The dictionary.
We find it.
Dictionary.
We find this in dictionary. Then we append in stack the car itself. So in stack it's gonna have this.
Yes.
I think I don't need the dictionary. You can go to the string character by character and push, and if you لو لقيت close parentheses you can compare drop and compare, and if this equal continue, if not return false, and continue in string character.
Let's try to complete.
I think.
Okay, so like just to keep in mind, there's many ways to do it, guys. Okay, let's just follow this one. This solution is like it need a hash map. It need a hash map and it need a stack. Is it the best solution? Maybe not. Do we care? Maybe not. But let's just enjoy this solution.
Okay, let's just focus on this.
Yeah, let's try to solve it with a hash map and the stack.
Okay.
So if it's not a closing bracket, that if it's not a key in the dictionary, you can use an else statement.
If the key is not in dictionary, but like okay, if the key is not,
that means that will only happen in the next iteration. We'll understand it.
That's mean like if this character is a close.
Yes. If it's not in the dictionary,
it is not K, but it is in value.
Like else or LF.
Else.
I think it's an else if actually, because you're gonna check if it's not in the keys, and you're also gonna check if it matches the last elements of the stack. And the actual else would be if it doesn't, then you return false.
We can combine them. You mean like combine the both case?
I don't
like the case that the character doesn't exist in stack. And
so if it's a valid close, it must not be in the keys, and it must match the close-in version of whatever in the last element of the stack. So it's technically two conditions.
Okay, guide me through that.
Use an else.
So it's not in stack. Okay, wait, I lost idea.
If we use an else, then where would it fail?
We are going to return if we check in the else, and if it doesn't exist in other key, we are going to pop the stack and compare. If the comparison work, we will continue the loop. If it doesn't, we are going to return false.
I have a question.
Exactly, yeah. So an if, an else if, then an else.
Someone had a question? Please go ahead.
Yeah. I think it's if maybe.
Can I write down?
Ebenezer, yes, go ahead, please.
Okay, so first and foremost, the choice of choosing if else or if any else is dependent on how many, for example, now, if you're going to pick one out of two options, you know if else is the best to use, but if you're picking one out of three or more options, then if any else is what to prepare it to. So in this case, it's like that we are picking one out of two.
It's really hard to hear you. Not sure, guys, you can hear him. I can.
Can you hear me now?
Yes, better.
Okay, I'm just trying to say that the choice of using if any else is dependent on the number of options we are taking with, and how many are put out of that option. For example, maybe if you are picking one out of two options, then if else is preferable to use. If you are picking one out of three or more, if anything else is preferable to use. So I think we can use that as a basis for choosing which is preferable to try.
Okay, I couldn't hear, like, I couldn't understand what you
It's
said.
hard to
Maybe just write and I try to read it out loud.
Yeah.
I have a question.
Yes, go ahead, please.
So, okay, thanks. So, just bear with me for a moment. Are we checking a character from the string to see whether it's a valid parenthesis, like round bracket square? Are we doing that?
No.
We're not.
Yeah.
So can someone please explain why we are doing if the character is in the dictionary, then we append?
Okay, so we want to keep track of all the opening brackets. We are going to go through a string. We keep track of all the opening brackets. So that's the way we can check if a particular character or a particular bracket is an opening bracket. That's why we are checking it. If it's an opening bracket, we put it in the stack. If it is not an opening bracket, then it's a closing bracket. We will go ahead and check if it matches the last opening bracket. Did that make sense?
Yeah, yes. What you're saying makes total sense. Yes. But then again, dictionary it's a dictionary, right?
Yes.
Okay. So, if the character is in the dictionary, then we append the character to the stack. Oh,
Yeah.
okay.
Because this
Okay,
one checks just the keys.
Yeah. My bad. I think I misread. Please, let's move on.
No, you good.
It's fine.
Okay.
Since it's just a two-way thing, it's either the key is in the dictionary or not. So we cannot. It will be safe to use an else.
Okay, if it's not in dictionary, that means it's close. It's close.
Yes.
Right?
Yes.
So that means this elf is gonna work.
We don't need an else if. Or we can say else if, not in dictionary.
Okay, let's do else, then we try to convert it to LF if it was possible. So else?
Else we pop the stack.
But
what if it's not a valid close?
We are going to get it. If we pop the stack, we are going to compare. We are going to compare. When we put the stack, we are going to get the last opening bracket, and we are going to get the value of the character. When the value of that character, like we are going to use that key the character as the key now to access the dictionary and check the value. If that value, if that
You have
value
to save it
matches,
into a variable.
Okay, so you're gonna pop, let's say this, right?
yes,
You're gonna pop this and take it to the key to get the value of it,
yes,
and then check if the character is equal this,
yes.
or equal or doesn't equal.
It has to be equal to the thing that you've just gotten. So you've just popped it from the bracket. Now you're going to check in the dictionary that holds the thing that it's pay.
Okay, I need to save it somewhere. So like, let's say
bracket, closing bracket.
Closing.
Yes.
But
or
it's
opening
open.
bracket in this case. Opening. Sorry about that.
Let's do just temp and then we figure it out. So we pop this. Now we have this value.
Yes.
And then
we use it to access the dictionary.
Now dictionary temp. But like we need to do something.
We're comparing it, right?
If
we're doing an if.
Yes, we let's just save it to something.
Yeah, we saved it to temp.
Okay, temp. Temp. Wait, let's put this here directly.
Okay, that's fine.
Okay, we have now this value.
Yes.
This value. Now.
Yes, so compare with character.
We have this value. But like, why we do it in temp? Because we are checking. Why we need this character check? So it's all about f. That's what I think Sabah said, LF, so we can check if this.
No, let's just continue with this. Let's just continue with this because we already have the character, and that character is closing bracket. The character we have is not a closing bracket. Okay.
Okay, character, and this is closing. Let's call it closing. We need to check.
Yeah, so let's check if closing is equal character. Yes. We can decide to continue. Or we can check if closing is not equal to character, we return false. If it doesn't, if it equals character, we just pass it.
Okay, but yeah, that's what I'm saying. Like that's what I think Sabah said. We can do like LF doesn't equal character, then return false, right?
Okay.
Yeah, that's safe. Same thing.
But I forget what else. You guys said something about other condition here. Okay, let's see if this is working.
Ooh, wait. We need one last
else,
thing.
you're just gonna continue the loop.
Return true at the end. We're going to return true at the end of by when the loop finishes.
No. There's one condition we're missing.
Which one? Okay.
The one condition we're missing is that if they're all just opening brackets, we have to check whether or not the stack is empty after this loop.
Okay.
So if they are like just like this, let's test this case. 3, we have this. So we're gonna do for character in string, if character in dictionary. Okay, it is stack append character. Okay, we append it. It's right here. And then we're gonna loop again. We're gonna go to the second one. Again, it's gonna append it to the stack. Again, we're gonna loop. It's gonna append it to the stack, and yeah, this return false.
We can use a simple flag to say that when that flag can be kind of variable. If character in dictionary, that means we have seen an open bracket, so we can say a particular character equal open, like a string. We can say it's equal open. Whenever we close, we say it's equal close. whenever it opens. So yeah, if at the end of the day that character equals an open, that means we have been opening, we didn't close to the end.
True. Or we can just check the length of the stack, because essentially the stack should be empty at the end of the loop if it's a well-formed bracket thingy. There should be nothing in the stack after we've popped to find its opposite.
Let's try it on this example. Let's try to do simulation of this code on this example.
Okay.
Let's see. So we have dictionary. Let me remove all this noise. Sorry guys, OCD. Okay. So we are now in this one.
Yes.
The stack is empty. Okay. The stack is empty. We add this. No. Wait, the stack is empty at first, right? So if character in dictionary, yes, it is right here. Stack append. Okay, we append it.
Yes.
We move. This is gonna loop again. We move to this one. Oh, let's see what's gonna happen here. So if character in dictionary, let's see, it's not here, it's not here, it's not here. What's gonna happen? This is gonna be false. We're gonna jump to LF. Else if dictionary stack pop. Okay, we did stack pop. What's happened is this gets out from the stack and to dictionary of this character, which is this one, it gives us this value. Now we are comparing this value with car, and car is this. So car, is it like doesn't equal this closed one? Is this true or false? It's true, false. So what's gonna happen? It's not gonna enter the here because it's false.
Yeah.
Please, if I did go fast, like you can pause, ask question, open mic and talk. Feel free. Okay, so the stack is empty now, and then we loop again. When we loop, we are here. Is this character in dictionary? Yes, it is. Again, the same. We add it to the stack. We loop again. Is this character in dictionary? No, it's not, because this one is closed. Now we're gonna check second else if. But before we do that, we're gonna pop. So it's gonna pop this, and it's gonna compare again. It's gonna compare this character with this condition. It's gonna dictionary stack pop. So it's gonna compare the value of this, which is this right here, with character, which is this one. And this one are not equal. So it is true. Is it true? Yeah, is it true? This is true, right? Let's think about it slowly. So we have this one, and we have this one.
No, it's not.
This is like circle.
Okay. Yeah, it's true.
So this one doesn't equal this one, which means it's true. Yeah, they are not equal, which means it's gonna enter this loop. What's gonna happen? We're gonna return false.
Yes.
But is that what we want?
Yeah, because we find.
Wait. Oh wait, I think I did mistake. Sorry guys. Sorry. Yeah, I did mistake. Let's roll back here. This is mistake of design. That's all. because this one is not a square. This is not parenthesis. This is square bracket. Oh my god. Okay. Okay, so this one is square. This one is square brackets. I hope it's clear now. But we did see if it was parentheses, it's gonna fail, which means the code is working. But let's make sure it's working when it's correct. Let's remove this noise. Oops. Okay. Okay. Now we go back here, right? And we gonna do in character. It is in dictionary. Yes, it is. So we're gonna add it right here. Hope it's clear. Now we're gonna loop again. Now what happened here is it's not gonna enter the first loop, second if, which mean dictionary. It's gonna pop this. Right here is it, more clear, and check if this condition with character, which is this one. This is the character.
I think not this, the value of this, the bracket, open bracket.
Oh yeah, true. So the value, yes. So here it's a bit confusing, but like this part right here, it's gonna pop this stack and the value of it, which is this one. So basically it's gonna be like this, checking this, which means it's gonna be false because these two are equal, which means it's not gonna enter here, it's gonna keep looping. Okay, so I think the algorithm is working, but it's missing something. I think we are close to find it. Now we loop to this one, and this because we did pop here, it's removed from stack, so stack is empty. Oops.
We need just add a condition for the stack, if not stack.
Something like that. But let's find it. Now we did loop here. Now this is exists in the key stack, right? Dictionary, so it's gonna add it to the stack. So here is it. We're gonna loop again. This gonna come here, and what's gonna happen? It's gonna enter the LF. The LF gonna compare with the dictionary stack pop. So it's gonna pop this, and this, the value of this is this one. So it's gonna compare the value of it with the character, which is this one. Is these two doesn't equal? They are equal, which means condition is false. Which means which means condition is false. If this condition is false, that means we're not gonna enter here. That means we're not gonna return true, false. That means our code is gonna try to loop again, but there is no more character. That means our code gonna finish here, but we should return true. Do we just write return true here?
No, we are going to check if the stack is empty. If the stack is empty, we return true.
Why? Why not just return true?
Because if we only had open
in case of what?
The open parentheses, we will go to the end, but the stack won't be empty. Open brackets. You can do open brackets to check
the stack. Okay, we need to check the stack if it's empty.
Okay, but why this? Why if it return true here? Like it's gonna finish, then we're gonna return true.
It's like two conditions.
Oh, you mean what if we still have some character inside?
Yeah. If it is empty, it is return true.
So why we can't do this true right here? Because what if we still have character? If we still have character, we should return false.
I think.
Yes.
Right? So if we still have character, so we need to check the length of the stack. Because
just if return not stack, maybe it's
so we need to check if the stack have something.
Yeah.
So here
if If
LF?
No,
len stack
just return. I think just
false,
return.
no,
Not
outside of the for loop.
not stack. Not stack.
Okay, so
It has to be outside of the for
Outside the
loop.
loop, outside the loop.
oh, yeah, outside. Okay, so if here, if stack. So we have something in stack, then return false.
Can you do
you
that?
can do it. You can do it, but you can do it just like in
No.
one line.
True, right? But like this is the this, what is called like before we make it short, like this is that's what we're trying to do, right? We're saying if stack have some elements, it's gonna return false.
Yeah.
If the stack doesn't have any element, we're gonna return true, which means like all good. Now with this we can make it short in like return
the
stack. No,
not stack.
Not stack. Because if stack is have elements, I need to return false. So I need to switch this value. So I can remove this line. It's same. But are we missing some condition?
The length, no? Can we just return stack?
Yeah.
What language is this?
So
because if you did like return stack,
I don't know. If I'm empty, if I'm empty list, give false.
wait, let's Python. Okay, I'm not sure. Sometimes I mix JavaScript with C, with Python, with everything.
Everyone does
yeah,
that.
it's trauma, man. At least you didn't put a semicolon, bro. Just pop it in the compiler. We'll see what it says.
Okay, let's try it here. So let's create a stack. Stack. So if this empty, and it's gonna return, it's gonna return the array, not the value of it, right? So let's continue. Let's return, or like print.
Not stack maybe.
But is the return the same as print? Print. So if we did stack,
return would only one function.
It's like what? True?
Just no, don't say just
like
stack.
Stack. It's gonna give stack the stack itself.
Okay.
But so we need to use length. But how it work here?
Print not
when we
stack.
do
Print not stack.
here, right here. Let me return. When we do like this, if stack.
So just do write not stack, and check. Go back.
Is a stack or
not stack?
Are we supposed to check? We want to check the length.
True.
Okay. Append something in stack.
So it is the
append something. Okay.
False.
Okay.
So the not that does that. Not
is like is check if the stack.
Yeah, it's the not.
Like is equal.
So now we have stack have element. With the not we can do stack. Okay, so empty is gonna be true. So that's what we want, right?
Yeah.
Okay, we learned something new. Nice. If return stack, it's gonna return the array, but if I did not, it's gonna allow me to reverse the value of true to false, or false to true, and true it means some element exists, and false means element doesn't exist. So this is supposed to work.
I think I do, but we can add not stack also in LF. if the stack if the stack already empty, or dictionary stack dot pop.
But
We
why
check
we
both.
gonna do that?
Both of there LF
Yeah, but why we gonna do that?
to check if the stack is empty.
Oh, you saying that
That means there
if
is
we're
nothing
looping through
open
string,
in
if we're looping through string, why we need to check the stack is empty?
because if the stack it's empty, that means
We can't
doesn't
pop.
exist any open.
Oh, we can't pop. There is no.
Yeah.
There is no element to pop.
Yeah, exactly.
Okay, what that mean? If there is no element to pop, that mean that element doesn't have the other part of it, right? If because when we do check
there is
here,
nothing to close them.
Because when we check here, we always check when it's close, right? If we check that when it's closed, that means before in stack it should not empty because it should have something open. Okay, that's smart. Okay, so not do we do stack? Else
Not
if stack and
or.
Okay, so why
we do not for check to
if we
to
did
see
not okay, let's split it. So when I wanna return false, when I don't have element here, right?
Yeah.
If I don't have element here, it's gonna be stuck is gonna be false. So if it's gonna false, this not gonna work. So that's why it's not, because we convert not false to true, right?
So not stack.
Yeah.
And stack is empty, it's return true.
Yeah, but like why we did not? To convert the false to true.
Right? No. I don't think so. Not
okay,
stack.
like because stack is gonna give us true.
Yeah.
But
we don't need the.
But like if it is true,
okay,
we're not gonna enter.
If the stack is empty.
Okay, wait. If stack, okay, like when do I wanna return false? When stack is empty, right?
Yeah.
Okay, now keep that, focus on that. Stack empty.
Yeah.
That means S, the value of S is false, right? If I check the length, or like the stack is false, right? Now if I put stack alone here, it's like I put false. Now if I put false, and it's gonna give me always false, because and it needs true and true to be true, and I need to enter here, so I need this condition to be true, right? So I need a way to convert this false to true. That's why I did not, because when I did not, it converts false to true. That means when this, you know what I mean?
Let's do
like, for example,
let's split it.
For example, this is empty, right? But look, it's giving me true. It's not giving me false, because I convert it with not.
Yeah, that is what I need.
Yeah, because if a stack is full, or like a stack have elements, I don't want it to enter.
We need true to enter inside this statement.
Yeah, but like we need true when the stack is empty.
Yeah. Already we need the stack is empty.
So not is the way to do it. Okay, what if we didn't do the stack here? We remove this part. It's just gonna be we're gonna miss the case where there is no I forgot how to say it. Like there is no open. We're gonna forget the case where we are checking for closest brackets and the stack is empty. There is no open bracket.
Let's try and test this code and then say what.
Yeah.
And also there is and it's all.
Can you repeat?
It's or, not and. In LF.
Not and. It's
Yeah.
or. So this
Just
or
one
this.
of them. You have true.
It's or. Okay. Okay.
I think so.
In that case, we can just do or right here. Stack or. Wait, I'm confused. Why or?
Because like if the stack is empty,
we should use stack.
There is not make sense or not. It's to check if the bracket is equal or not, and also okay. I'm just confused.
The way it is,
okay.
It's not good. The way it's perfect. If we want to get to understand it, we can split it into different lines. But the way it is now, we don't need that knot.
Yes, let's split it.
Okay.
Yes, someone wanna say something?
Yeah.
Yes.
Can you hear me?
Yeah.
Yes, we can.
Okay, the reason why we are putting the stack there to begin with is just to confirm that the stack is not empty so that the pop works, right?
Yes. Yeah, because
Okay.
when we reach this position we're like
the reason why no need for not stack is because if you put stack and then dictionary, right, the and there.
Like that?
Yeah, okay, so I'm saying the reason why you don't need the not in front of the stack is because once you say else if stack, so if the stack is not empty, right, and you're using the and operator, it's going to be fine, because if it is empty, it's going to be 0, so the operation wait, hold on, I think I just lost my thoughts.
Yeah, also like
okay.
This part is very confusing. Maybe we should do like, maybe I should write it.
Split. Yeah.
So
let me try to explain. As one of the stack is contains something. When the stack contains something, we proceed to check if the dictionary, if the key, if the value of the key compared with the character, if they are not equal, that's the only time we get into the else if block. So first, stack must contain something. If stack doesn't contain something, if the first, when we if stack, when we're really just putting stack there, only when stack contains something, that is when we continue processing.
Okay, so it's gonna work. It's gonna work here.
Yeah.
Because if stack contains something, this is gonna be true.
Mm-hmm.
And then end. So this to be false. This should be both. True. True.
Yeah.
But like there is a case where this is gonna be true.
Yes. We must have something in stack before we are able to pop.
Like we just need one of them. True and false.
Okay, let's
try to test the code and then see what.
Okay, we can test the code. Then if it didn't work, we try to keep, because I need another coffee, I guess. Okay.
I do.
If we run this, if we divide it, there's an optimization we can make and make the code even better. If we can do it in different lines, we make the else if block in different lines.
Okay, so if we did it in different line, we're gonna do 2 other false return, right? So like it's gonna be yes.
You need to complete the dictionary.
We are going to check
empty.
I just use an
we need to add the bracket and also this.
Yeah, continue please.
Yeah. So I was saying if we kind of use multiple lines in the else block, you would be able to check. For example, if the first thing we have in the string is an open bracket, there's no point going further to check. So if we can make the else block
here
to capture, maybe we have.
You mean check here? F
no,
or
no, like In
How?
the else block, in the else
Here.
block,
Do we do another block?
if we use else, if we use else, no, if we use else, where we are using else if, immediately we get into that block, that else block, we know that we are having an open bracket.
Yes, so I
we
do
have
else.
an else block. Immediately,
Wait.
yes, immediately we get in the, we know we have. Just do else. Go
Okay,
to the
but
next line.
how I
Else. Just
can
do else
write
and go to the next
condition?
line.
So I do else and the if inside.
Go to the next line. Go to the next line.
What? Can you repeat?
Yes, if stack, if not stack, if they make the condition, if not stack, so we return false. If not stack, return false. No, you are going to remove the other and. You are going to remove the other and. The other and block in that if block. We are going to remove the other and.
Like this? Or?
Bring the other and down. No, just bring it down. Just bring it down.
What does mean bring it down? Like
the if not stack should just be its own. If not stack should just be its own condition. Yes. So return false in the other part. Yes, return false. So if the first thing we have is an open bracket, yes. If it's an open bracket,
yeah, but
we
this
should
is
just
or.
return false.
This is or.
Yes. It's not false.
So like this is the same as
yeah, it's kind of or yeah.
But like why is and okay, let's keep this in mind. Let's make copies. But let's check if and is gonna work. Because I'm still confused about the end and or, and I try to understand it, and like my brain was like, okay, enough. Okay, so this was the code, right?
Yeah.
Let's see what's gonna happen.
Something.
Oh.
You forget.
I think here I double colon. FS. Okay, what's else? What's run?
I love errors.
Return false. Uppercase. Okay, it's work.
Yeah.
Okay, let's submit.
It has many solutions for this.
Okay, there is a case where it doesn't work. I guess that's why we need or.
Yeah.
But I just can't catch it in my mind. Okay, let's do the or.
So let's see the let's see the case.
Okay.
Let's see the case. Yeah, good.
One closing bracket.
One closing bracket.
True.
Okay, because what happened, I think
closing bracket is
they need both of them to be true, which it will never be true because there is nothing to pop.
That is
right. That's why it didn't work. Now let's submit with or.
Yeah.
Okay, it worked. Nice. Let's clap. Nice.
Wait, before you clap, wait. I didn't got why we need not.
Nuts.
Wait.
Okay.
Because not stack. If stack is empty, not stack it's return true. If it's return true, it's enter this if statement.
I solved it with.
Yeah, I'm an advocate for readability. So not stack means it's empty.
Yeah,
it's the equivalent to length stack is equal to 0.
Okay, we can do length. This is a good point. Equal 0. Right?
Okay.
Yeah.
So we say that if the stack is empty, it has no opening brackets. So false. Okay.
Yeah, because if I go to this character and I go, okay, let me see add it to the stack, then I add it, then I loop again to the second character. If I am in second character, or like if I am in any character that doesn't exist here, it means the character that I am on is a closed character.
Closing.
So one of this. Now, if I am in closed character, automatically it means the stack should have something, right?
Yeah.
If I am in closed character and the stack is empty, automatically that means I did not have open before. So that's why that's why it means like if the stack is empty and I am in closed character, just return false. There's no need to waste time. So this one or we can do it like to be more else if return like this. Yeah, so either the stack is empty, we're gonna return false, or dictionary is not match, the doesn't match. So one close, one not close. I mean one open, it should match the one close. Or something, I don't remember one of them. But basically this one should not be true. If it's true, it means there is a mismatch. Okay, now we can clap. Good job, guys and girls. Nice work. Okay, we did go through 2 hours. Maybe we keep it like here so the session don't go that heavy.
Yeah.
Also, my brain is shutting down. Yeah, the solution is nice. The next LeetCode that we were gonna do is this one, merge two sorted lists. I think we did it so it's easy. So in the last 5 minutes or 10 minutes, we can watch this video just like again, just to check it. Let me share screen.
Munsif?
Yes, boss.
You pass. My solution is 127 lines.
27 lines.
100. 127.
Did you make the stack?
Yeah, I'm beginning to hate C after hearing what he said.
We're using C. If you're using C, you have to make your own stack, yeah?
Yeah, I using step with linked list, and I using ASCII code with parentheses, and the time is 0 milliseconds. This is. I used the last problem with the linked list. Linked list, yes.
I don't recommend you see like take interview because it's gonna be I don't know, maybe you're gonna maybe it's gonna be impressive. Okay, let's watch this video. It's about last LeetCode. Let's see.
And let's solve another LeetCode problem, merge two sorted lists. So this is an easy problem. It's a mainly fundamental problem. There's nothing crazy about it, but it's a pretty good problem to understand some basic stuff. So we're given two linked lists, right? So this is the first one, this is the second one. Both of them are already sorted, and we just want to merge them into an output linked list. The only catch is that we have to use the original nodes, right? Like we can't create copies of the nodes. So let's say we have list 1 and we have list 2. I'm just going to take them exactly from the example that they gave us so we can actually focus on the general algorithm itself. So your intuition will probably solve this problem for you. So it's basically, since the lists are sorted, we start at the beginning of both of them, right? Now we can just compare the values. So they're both 1, so it doesn't really matter which one we pick. So we can just take, I'll say list 1, right? So we'll take this one and insert it in our output and then move to the next one and then just continue the algorithm. The only catch here is that right now our output list is empty, right? So this kind of gives us an edge case because we don't even have a list itself yet. So what I like to do is just create like a dummy node. So this is a pretty common technique, and you avoid any edge cases. You avoid the edge case of the initial empty list. So let's say we start out with a list, right? This is a dummy node. It can have any possible value. So now we're going to insert 1 into our list. Now we're going to compare two values of 2 and 1. In this case, the value from list 2 is smaller, so we're going to take it, insert it into our output list, 1. Now we're going to be comparing these two, so 2 and 3. The value from list 1 is smaller, we take it and insert it into our output, 2. And then of course we can move to the last value in list 1. So now we're at 4 and 3. Which one of them is smaller? Of course 3, which is the value in list 2. I'm running out of space, but I think you get the idea at this point. So now we're at the two last values from each list. We'll just take the value from list 1 and add it, which is 4. They're both the same, so it doesn't matter. Now, this is the last edge case that we have to worry about. So now, for list 1, there aren't any more values left, right? So we can't really continue our algorithm. Lucky for us, there's only one value left in list 2, but it's not always going to be the case, right? Maybe there could be a bunch of other values, right? 4, 5, 6. There could be other values in list 2. Now, what would we do in this case? Well, we can do a really easy thing, which is just take the remaining portion of the list. So if we run out, so if one of the lists is empty, of course, the list 2 in this case is still sorted. So we can literally just take that list, insert it into the end of our result, right? So that's basically the idea. Okay, now let's write the code. So remember, I like, and most people like to use this technique of creating a dummy node, so you don't have to worry about the edge case of inserting into an empty list. The tail of our list is initially, I'm just going to say, the dummy. So now we're going to keep going. We're going to iterate through these two lists. What's the condition that we're going to do that? Basically, if both of them are non-empty, right? Because that's when we can actually compare the two values. So while list 1 and list 2 are non-null. So now we can do our comparison. So if the value of list 1 is less than the value of list 2, then of course we're going to take the list 1 value and insert it into our tail. So tail.next is going to be the node itself, right? List 1 node. And then we can, of course, update our list 1 pointer. Now, the else case is if list 2 is less than or equal, right? So if they were equal, the else condition would evaluate. So we're going to do the exact same thing, except list 2 is going to be inserted. And don't forget, we do have to update our tail pointer, but the tail pointer is going to be updated regardless of which node we insert into our list, so that's why I'm not putting it in either of the conditionals. And you might be tempted to just say return dummy.next, return the list, but don't forget, our condition was list 1 and list 2 are non-null. What if one of them is empty but the other one isn't right now? Well, in that case, we want to find the non-empty list and then insert it at the end of our result. So if L1 is non-null, then we'll say tail.next is equal to L1. So we're just taking that remaining portion of L1 and inserting it into the end of the list. Else if L2 is non-null, we would do the exact same thing with L2. Only one of them can be non-null. So let me just run it to prove to myself that it still works. And
is this gonna work?
Yep, it does. And some random percentages that always seem to change. Right now it's 65%, but I'm sure if I submit it again, it could be 10%, it could be 99%. I don't know why LeetCode is so inconsistent.
Okay, that's amazing. What next? Next is, by the way, if someone have a question, please go ahead. So next is we're gonna do tomorrow 3 LeetCode again. It's gonna be a bit harder than of today, and it's gonna keep going hard the more we go through. And the last thing I want to say is, think about this. So this is you, right? This is you right here, right? And this is your goal. For example, you want to work in Google, or maybe you want to work in Facebook, right? Or maybe you want to work on NASA. Who cares? Like, it's your dream. Now, to reach this dream, you need to do certain stuff, right? And now going through life, your energy is gonna go down, up, down, up. So what's happened is you start losing focus of your goal. When you lose focus on your goal, you stop attracting it. So what we want to say is, like, keep focus here and keep working like this, and yeah, one day we're gonna reach our goal. That was the session of today. Have a good night, everyone. Love you. Bye bye bye.
Bye 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 bye.